So now you know what activation functions are, and I'm going to now revisit the code that we looked into before. So this is what we did with our convolution neural network. We had a first layer which had 32 3x3 filters. Into that we fed in the input 28 by 28 by 1, and remember, these were the data that we reshaped to have this particular format. With every convolution network, or with every convolution layer, we also had a max pooling layer, like so, 2 by 2, and the second layer, it had 64 3x3 filters, followed by 128 3x3 filters and max pooling layers for all, and then these were flattened and passed into a dense layer from which we obtained the output layer. Ultimately, running the entire code, it took me 6 hours. So remember, if you run convolution neural networks, it can take several hours and you would need a lot of computer storage. But in the end, I get a testing accuracy of 99.3%, which made it worth my while. But anyway, let's just re-examine some of the code so that you have a better sense. So remember, these are the input data, X and Y. This is where we did the reshaping, and the -1 in this means that the program can infer it however it deems fit, but the rest of the predictors, they were reshaped to have the form 28 by 28 by 1, like so. Now we define the functions for the convolution layers and the pooling layers, conv2d and max pool 2d, and here k is equal to 2, because remember, we want a 2 by 2 max pooling layer. Then we define the weights, and here we start with 3, 3, 1, 32, because this is the first convolution layer which has 3 by 3 filters and 32 3 by 3. So in this situation, all of these are 3 by 3 because we are using 3 by 3 filters, which are commonly used filters for CNN problems. And indeed, you can go in for 4 by 4 or 5 by 5. This is something one has to experiment with. But as you can see, 3 by 3 filters, they worked well for me. So this is what we have, 3 by 3. And then since this was passed into this one, we'd say 32 and 64. Into this one, 64, 128, and so on. And then we defined the biases in the same way. 32, which comes from here. 64, which comes from here. 128 and 128, which 128 of the third pooling layer and from the dense layer, like so. And then we finally define the convolution neural network, and conv1, it takes the image as input, and we repeat the same procedure up to conv3, and we connect the flattened conv3 neurons with each and other neuron of the other layer. So once this is done, all the neurons are connected to the next layer, the fully connected layer, FC1, and then we obtain the output class prediction. So essentially, this is how this particular convolution neural network was set up. And indeed, for these kind of data that we work with, you can adapt the code or use the same parameters for your own convolution neural network.